Hello friends, welcome back to my channel Dr. Vijay SSOC. Today we are going to discuss about a very important NMR technique, which is two-dimensional COSY NMR. By the end of this video, you will understand what is COSY NMR, what is the importance of the COSY NMR, and how to interpret COSY NMR with the real examples. So let's start this video. So 2D COSY stands for two-dimensional correlation spectroscopy, which measures the interaction between proton-proton, and therefore it is also known as 1H1H correlation spectroscopy. Unlike NOSY, it occurs via the bonds, not via the space. Now, what are the importance of the COSY NMR? The COSY NMR is important to assign the neighboring protons in a molecule because it gives the correlation between the adjacent protons. For example, Vyvyan protons, which is 3 bond interactions. When you have a Vyvyan protons in a compound, they will show the interaction in the COSY NMR, and you will see the intense spots, or we can say that cross peaks, in the 2D COSY NMR. Usually allylic system can also show the J4 coupling, but those couplings will be weak, and therefore you are going to see the weak cross peaks. So remember that Vyvyan protons will show the strong cross peak with the high intensity, and if you see the weak peaks, this is because of the long range coupling. A very important point is that geminal protons do not show interaction in the COSY NMR unless they are non-equivalent. So these are the geminal protons. So they are not going to show the cross peak in the COSY NMR unless they are distereotopic. What does it mean? It means it must have chiral center in the adjacent position. Then only you will see the interaction of these two protons. Otherwise, you are not going to see. So what are you going to see in the COSY NMR? Usually Vyvyan protons interaction and weak cross peaks due to the long range coupling. Now we will see how COSY NMR looks like. So this is the example of the COSY NMR. So in this NMR, you can see that the x-axis, or you can say that horizontal axis, have 1H NMR from upfield to the downfield region side, and on the vertical axis you have another 1H NMR, and both the NMR are same because it belongs to the same molecule, but it is aligned in a different way. Now you can see here it is the downfield region and there is a upfield region. Okay, so what will you see in the COSY NMR? So two types of peaks you are going to see in the COSY NMR. One is diagonal peaks. So you can see that this is the diagonal, and there are how many peaks? 1, 2, 3, 4, 5. So what does it mean? So similar to 1D NMR, diagonal peaks represent the chemical shift of the protons. So what diagonal peaks are representing? These are representing the chemical shift value of the protons. So this peak correspond to A proton, and this peak correspond to B proton, and so on. These don't give information, so they just act as a reference. Okay, so they are not going to give you any information. And another peaks are cross peaks, which are off diagonal peaks. So across the diagonals, the peaks which you are seeing, this is called as off diagonal peaks, which indicates that two hydrogens are coupled to each other. Usually this means that those protons are on adjacent carbons, or we can say that vicinal couplings, 3 bond coupling we are seeing. So how to interpret this one? So there are two ways. First is that you take the diagonal peaks and draw the horizontal line like this and see if this is connecting to any cross peak, right? So this is connecting to this cross peak. Now draw the vertical line from this, and it is connecting to this diagonal peak. So it means that this peak and this peak are correlating to each other. Therefore, we can say that proton A and C are in the adjacent carbon. So what we can say that proton A and C are on the adjacent carbon. Okay, sometimes we see that there are several other cross peaks. So how to identify the real cross peak? So to identify the real cross peak, the best way is that the first half of this spectra is exactly the mirror image of the second half. So whatever you are seeing in this half, in this area, you will see in this area also. So now you can clearly see that if you draw the vertical line, it is connecting to another dot here, right? So this is like a mirror image. You can see that this is like a mirror image, right? And if you connect this one, so it is making the square. If you see the formation of the square, then you can clearly say that this is the real cross peak. If you don't see the cross peak other side of the diagonal, then it means this is not the real cross peak, or we can call it symmetric pair. Actually, this is called as symmetric pair also, symmetric pair. Now look at the diagonal peak B. If you draw the horizontal line, then it is connecting to the D. Now you can draw the vertical line from this D, and it is connecting to the this one, which is D, right? So what you can say that B is interacting to the D. So these two protons B and D are adjacent to each other, and you can see that across the diagonal there is a peak, and if you connect you will form another square, and so on. You can do in this. You can see, you can interpret this spectra very easily. The another way to interpret this COSY NMR is that just take the cross peak, draw the line from this cross peak, as you can see that, and on the other side, and see that it is corresponding to which proton. So you can see that this is corresponding to the C and A. So this is the another way to check the interaction. And here also you can do that. Let's take this cross peak and draw the line. One line, this is vertical, and another horizontal line, and you can see that this peak is due to the interaction of E proton with the B. So E and B are in the neighbor to each other, or we can say that they are vicinal protons. I hope it is clear to you how to interpret the COSY NMR. So remember this point: the first half of the spectrum is the mirror image of the second half. But this is not true for any other two-dimensional NMR. This is only true for two-dimensional COSY NMR, not for HSQC or HMBC. Okay, now we are going to understand the COSY NMR by another example. So this is the COSY spectra of the 2-nitropropane. So there are two types of proton. One is this, another is this, right? So this is belongs to the methyl proton, and this is belongs to the CH proton. Now you can clearly see that there is a diagonal peak. You can draw the horizontal line and then vertical line, and this cross peak indicates that this methyl is interacting with this hydrogen, as you can clearly see in the structure as well. And hence we can clearly say that CH3 is in vicinal position to this hydrogen. This is forming the square as well. Look at the other small signals, for example this one and this one. This is coming from the impurity, because you can see that there is a small impurity in the sample. So these interactions is due to the impurities present in the sample, not from the structure. So you have to understand that some signals may arise due to the long range coupling and due to these artifacts of the solvents. Let's see another COSY spectra for our better understanding. And you can see that all the hydrogens are already labeled, so it is very easy for us now to understand. So what we should see, the interaction of 1 with the 2, right? So where is the 1? This is the peak, diagonal peak for one hydrogen, and it is, if you draw the horizontal line, it is connecting to the 2. This is 2, right? You have to draw the vertical line as well. So this is connecting to 2, and it is making the square, and this is very intense also. So intense peak means this is vicinal proton, and you can see that, yes, so this interaction we found. Now let's look the another interaction, which is the interaction of 3 proton. This is the horizontal line which is connecting to the this dot, and now we are drawing the vertical line which is connecting to the fourth. So proton 3 is interacting with the 4, right? So it should be vicinal. Let's check in the structure. Yes, 3 is interacting with the 4. So we found this interaction as well, and you can see that across the diagonal there is another peak, so it is making the square. Okay, what about 6, proton 6? Because there is no neighboring protons, right? So let's look at the 6. This is the peak 6, and now if you see that there is very small weak peak, right? Across the diagonal also I can see that. What does it mean? If you connect, it is forming the square also, right? But there is no hydrogen in the neighbor. But it could be long range coupling. Let's count it. So this is the 1 bond, this is 2 bond, this is 3 bond, this is 4 bond, and here is 5 bond. Hydrogen, yes, there is a hydrogen. So it is showing 5 bond coupling. 5 bond coupling is possible with the weak interaction, and you can see that this is the weak interaction. And another reason for the weak interaction could be the spatial arrangement of the molecule also. So there are two reasons. One is long range coupling, which shows the weak interaction beside the long range coupling. Another is orientation of the molecule in the space. We know that the COSY interaction is not through the space. So what does it mean? So it means that when the molecule coming in the close proximity, there could be an interaction like hydrogen bonding or some kind of other weak bonding interactions, and that could transfer the effects from one bond to another bond, and this could lead to the formation of the weak signals. And you can ignore those weak signals. We just have to focus on the strong spots, intense spots. Now let's try to find any other interaction. Okay, so there should be an interaction of proton 2 with the 3, right? So this is the 2 and 3. Yes, but this is very, you have to zoom it. To see this interaction, you have to zoom, because look, there is a 2 and they are in a close proximity. So I'm making the square. This is the square for me. It's connecting the C. Okay, so we found this interaction also. So I hope now it is very clear to you how to interpret the COSY NMR. If you have still any doubt, you can ask me in the comment box. So don't forget to subscribe my channel. We will see you in the next video. Thank you very much. Take care. Bye bye.